All right, let's solve this step by step. First, let's sketch the graph of the function. For x less than 0, the graph is the straight line. Y equals 2x. For x greater than or equal to 0, the graph is a quadratic. It has roots at 0 and 4, and it reaches a minimum point at x equals 2. If we substitute x equals 2 into k times x times the quantity x minus 4, we find that the minimum value is negative 4k. In this problem, f of t means the y value of the function when we plug in the real number t. For example, when t equals 0, f of t equals 0. In this case, the graph of y equals f of x, and the horizontal line y equals f of t intersect at 2 points. So h of 0 equals 2. Now let's check the number of intersections between f of x and f of t, depending on the value of t. Case 1. If f of b equals negative 4k and t is less than b, then h of t equals 1. Case 2. If t equals b, then h of t equals 2. Case 3. If t is greater than b and less than 0, then h of t equals 3. Case 4. If t equals 0, then h of t equals 2. Case 5. If t is between 0 and 2, then h of t equals 3. Case 6. If t equals 2, then h of t equals 2. Case 7. If t is between 2 and 4, then h of t equals 3. Case 8. If t equals 4, then h of t equals 2. Case 9. If t is greater than 4, then h of t equals 1. If we draw the graph of h of t, it looks like a step function, similar to the floor function. From this graph, we see that the points where the difference between the left-hand limit and the right-hand limit of h of t equals 2 are t equals b and t equals 4. At t equals b, as t approaches b from the left, h of t equals 1. As t approaches b from the right, h of t equals 3. The difference is 2. At t equals 4, as t approaches 4 from the left, h of t equals 3. As t approaches 4 from the right, h of t equals 1. The difference is also 2. The problem tells us that the sum of these t values is equal to 2. Therefore, b plus 4 equals 2, which means b equals negative 2. Now substitute x equals negative 2 into the line y equals 2x. That gives f of negative 2 equals negative 4. This must equal the minimum value, negative 4k. So negative 4 equals negative 4k, which means k equals 1. Thus, for x greater than or equal to 0, the function becomes f of x equals x times the quantity x minus 4. Finally, let's evaluate. At x equals 1, f of 1 equals 1, times the quantity 1 minus 4, which is negative 3, and at t equals negative 1. The horizontal line, ds equals f of negative 1, intersects the graph at 3 points, so h of negative 1 equals 3. Therefore, f of 1 times h of negative 1 equals negative 3 times 3, which equals negative 9. Final answer. fa of 1 times h of negative 1 equals negative 9.